Hello everybody and welcome to the second lecture of MIA 320. In this lecture we are going to talk about engineering history and modern era. I have prepared quite a long presentation since I need to cover lots of material in a short period of time, so the pace of presentation will be a little bit high. We are going to start talking about hunter-gatherers, and after that we will move towards industrial revolution and what happened between hunter-gatherers and industrial revolution. Let's start with origin of early technologies in the Stone Age. The hunter-gatherers in the savannas of East Africa some 2 million years ago were living in groups, moving around to take the advantage of seasonal variation in plant and animal life. They developed simple portable tools made of wood and stone, normally by using fractured stone to produce a sharp edge for cutting. Their technological development included controlled use of fire, fashioning of clothing, and early form of arts. The development of agriculture was a critical turning point in human history. A warm climate and annual cycle of flooding in fertile river valleys provided favorable conditions for crop growth. One such area was Mesopotamia, the fertile crescent of the Tigris and Euphrates valleys in the Middle East and the Valley of Nile in North Africa. This picture shows the independent center of origin of agriculture and its spread in prehistory. But before I start speaking about this picture, let me give you a little bit of information about the abbreviation that we use for years. There are three abbreviations here that we use in this slide. When we are saying BC means before Christ, BCE before Common Era, BP before present. BC and BCE are the same. For example, when I say 5000 BC, it's the same as 5000 BCE. No difference. But when I'm saying 5000 BC, that 5000 BC is equal to 6950 BP. Okay, it's very simple. Okay, let's go back to the figure. As you can see here, the first, it's here, let's talk about. It is believed that around 11,000 BP, agriculture first emerged from modern-day Middle East and Fertile Crescent. This area is the birthplace of wheat. The second center of origin of agriculture is believed to be at the Yangtze and Yellow River Basin in modern-day in China, here. Number 2, around 9,000 BP. It is also believed that rice is originated from this area. Agriculture also developed independently on the island of what is known today as Papua New Guinea, around 9,000 to 6,000 BP here. It's number 3. The next three origins of agriculture all believed to start independently, more or less 5,000 to 4,000 BP. In different parts of the world. In Northern South America, the birthplace of potato. Central Mexico, the birthplace of maize. And an unknown place in sub-Saharan Africa, the birthplace of yams. The next independent origin of agriculture shown in this picture is in the eastern modern-day United States and around 4,000 to 3,000 BP. This one is the last one. Okay, let's go to the next slide. Agricultural Revolution. Agricultural Revolution or First Agricultural Revolution is the process in which the hunter-gathering lifestyle transferred to that of agriculture and settlement. Be advised that sometimes in the literature, British Agricultural Revolution of 18th century is called Agricultural Revolution as well. But here, when we say Agricultural Revolution, we are talking about the first Agricultural Revolution that started around 11,000 BP. This video here is a very interesting video. Shows the world population growth from 100,000 BC to up to 2015, and also estimates the world population by 2100. But what we want to see from this video specifically is the influence of agricultural revolution on world population. So the timeline that we are interested in is between 47 seconds and 52 seconds, but I recommend you to watch the whole video because it's really interesting. If you focus on that period that I told you between 47 seconds and 52 seconds, it clearly shows a dramatic increase in the world population due to agricultural revolution. An increase in the world population was not the only influence of agricultural revolution. Social changes such as specialization of labor, support of aristocracy, people settlement, and the possibility of cities due to the food surpluses, and create a support for technology development. But having more population and settlement into the city also resulted in disease and war, and of course, very important, we can't forget about writing, which is another important impact of agricultural revolution. Human settlement after the agricultural revolution facilitated the widespread adaptation and improvement of tools. A wheel, the most important mechanical invention of all time, first appeared around 3500 BC in Mesopotamia. Building technology was initially constrained due to minimal transport facility, but after the invention of wheel and advancement of transportation around 3000 BC, building technology quickly advanced. Use of brick in Mesopotamia and using stone in Egypt are some of the examples. The pyramids were built between 2650 and 2190 BC with stones brought from far distances by Nile, and after that moved to the site by using wheel. The other important thing is a metallurgy revolution around 3500 BC. Around 9000 to 5000 BC, copper and gold were smelted from that time ago, but because of their softnesses, they were not that effective for tools. And it was the discovery of bronze in the Middle East in 3500 BC. That's the reason why we call it revolution, because that discovery made the tool making possible. So discovery of bronze basically was the metallurgy revolution. Otherwise, before that, the human being had the experience of smelting copper and gold. In this slide, you can see some of the examples of early engineering in two areas of metallurgy and building in Africa. I hope I'm pronouncing it correctly, but golden rhino of Mapungwe was first discovered in 1932 by researchers of University of Pretoria, and if I'm not mistaken is still held at the University of Pretoria Museum somewhere. Is one of the examples of metalworks in medieval kingdom of Mapungwe. Bronze sculptures of Benin is another example, and there are some, we mentioned some example of building technology in Africa. In India and China, so the system number of 1 to 9 first used in India around 1500 years ago. Also, the concept of number 0 is coming from India as well. In China, textile technology and silk weaving machinery were being used in the 1st century BC. Invention of paper in China, transportation and military technologies, all of them are some of the advancement of East. Greeks considered the foundation of European knowledge. They were really focused on liberal art. Thales in around 5000 BC attempted to explain the world on the basis of rationality. With the rise of Roman Empire, engineering practices became more clearly recognizable. especially road building. Roman engineers were involved with Roman armies to build bridges and solve technical problems during the war. And the term engineer comes from the Latin term ingeniator, meaning ingenious person. The scientific revolution started at the beginning of 17th century when the foundation of old order of society were shifting. Galilei, Francis Bacon, René Descartes, Robert Boyle, Isaac Newton, all of them are some of the big names that rose during the era of scientific revolution. The rise of capitalism brought about a renewed interest in trades and more practical approaches toward knowledge as well, so helped it. With ships and technological advancement in arms, Europeans had set out to explore and conquer foreign lands and seize new resources. Here you can see some of those efforts from 1000 to 1652. Spain and Portugal were leading the way, and then the Netherlands and England joined the race. The scientific transformation in social, political, and economical foundations, coupled with scientific revolution and constant improvement of mechanical devices, and especially in England, the weakening of the guild by passing anti-monopoly legislation led to the Industrial Revolution. This video is very interesting. Video gives you detailed information about the Industrial Revolution. I really recommend you to watch it during the lecture. You can pause this lecture and after that go and watch the video and come back and continue with the lecture. Abraham Derby in 1709 discovered how to use coal to smelt iron. His plant was at Coalbrookdale in England, and it was the center for innovation for nearly 100 years, and that city was the birthplace of Industrial Revolution. In 1698, Thomas Savery introduced the first version of a pistonless steam engine. In 1712, Thomas Newcomen developed a practical atmospheric engine to harness steam power, and then James Watt dramatically improved the effectiveness of and efficiency of a Newcomen engine by introducing a separate condenser to maintain it at a low temperature. Then James Watt started his partnership with Matthew Boulton, and by the end of 1700, 500 Watt Boulton engines were installed in England alone. Even though the pace of the Industrial Revolution was set by Europe, with France and Germany catching up to Britain, the challenge was coming across the Atlantic and from the United States. Britain's loss of technical leadership from 1850s onward reflected complacency and conservatism not only in its society but in engineering profession itself. The emphasis in universities in England on the pursuit of scientific knowledge for its own sake and not giving enough attention to practical and commercial applications played a big role in it, while in the UK the value of know-how was widely accepted. In Germany, the efforts toward industrialization started only when Bismarck became Chancellor of a unified nation-state in 1871. Bismarck's creation of a state-owned national railway system helped the opening of internal market, push to expand foreign trade, focus on exportation, German government role in promoting education related to industrialization, and importance of industrial research for German manufacturers all helped Germany in its industrialization process. Japan was a latecomer to industrialization. Matthew Perry arrived to Tokyo Bay in 1853 with the first steamship ever seen in Japan, with the demand from the US president for Japan to trade with the West. The external threat and the unequal treaties imposed on Japan from the West forced political acceptance of the need for rapid technological and social change in Japan. The Meiji Restoration of 1868 brought an end to Edo period and dismantled the feudal system in Japan. Now the question is, how about Africa? As we briefly explained here, different countries took different paths toward their industrialization. What African countries should do? This video gives an answer to this question from perspective of Carlos Lopez, an African economist and the former executive secretary of United Nations Economic Commission for Africa. It's very interesting video. I really recommend you to go and watch it. In this slide, we try to give a brief explanation on social impact of industrial revolution. In England, the birthplace of industrial revolution, the population tripled in 100 years. The trade decreased, transportation improved, and the living condition of people improved a lot. But due to extreme need for workers, the child labor increased, and automation received great attention to sort this problem out. But later, automation led to unemployment of less skilled workers. In this section of our lecture, we are going to talk about engineering in modern era, 19th century until present, and the role engineers played in shaping the modern world as we know it. We are going to talk about automobile industry and changes in production. We are going to talk about Taylor scientific management and modern manufacturing, fourth industrial revolution. We are going to also talk about engineering and infrastructure, and we end this section and today's lecture with two case studies. Okay. The development of automobile started well back in the 19th century. Attempts to develop new power sources by applying engine practices to internal combustion engine resulted noisy machines. The idea of four-stroke cycle was first came to the mind of a French engineer Alphonse Biot-Deroux in 1862, but the German engineer Nicolas Otto that 14 years later brought it to reality with manufacturing the first four-stroke internal combustion engine. A prime requirement for his engine was a suitable fuel. Okay, so during that time, gas produced from coal was being to be piped in many cities for cooking, but it was not suitable for vehicles. Toward the end of 19th century, when crude oil is distilled, the lightest fraction of it to be vaporized called gasoline, and it is looked a perfect match for automobile industry. In 1885, Daimler and Benz produced four-stroke engine that used gasoline. On the same year, Daimler produced first motorcycle and Benz produced the first automobile. Carburetor invented in 1893 by Maybach, and by using Venturi principle, that it's exactly the same concept that is being used even today. So with the same concept, he came up with the idea of carburetor. The electric self-starter for gasoline fuel engine first installed in 1895 on a car in Britain. Britain. The improved version of it introduced in 1912 by Kettering. German engineer Rudolf Diesel worked on the concept of a compression ignition system that could burn heavier fraction of oil. He was not alive when the first diesel engine came out to the market, but his work on the thermodynamic cycle of the compression ignition engine was not forgettable. During the early days of automobile industry, automobiles were assembled by highly skilled craftsmen. There were no standard models, and automobiles were made to individual customer orders, so no two automobiles were identical. To address this issue, Henry Ford introduced moving production line in 1930. Using a common gauging system throughout the manufacturing process, the development of high-speed steel cutting tools for machining preheated metal parts helped Ford to eliminate distortion problem. Model T of Ford was first standard automobile that was designed for easy assembly. The production line helped Ford to double labor productivity, partially because it brought the work to the worker and partially because it enabled Ford to control the pace of production. With these developments, Ford effectively eliminated the need of highly skilled craftsmen. To start with, annual labor turnover was as high as 380%. When Ford doubled pay rate to $5 per day, When Ford doubled pay rate to $5 a day, he held on to his workers, but there was little satisfaction in the work that they were doing. Mass production was successful in achieving Ford's central aim of increasing productivity and manufacturing cost reduction, but it had a negative impact for work and workers. Why? Because they were highly skilled people, and it was a little bit disappointing for them to just attach two standard parts together and make more automobile in a short period of time compared previously that they had to put their craftsmanship into work. The history of automobile shows that a technology needs to be considered in the wider social context. It also shows the difficulty of anticipating and controlling the social consequences of a new technology. The major concern at the beginning of this industry, it's a little bit funny, but the major concern at the beginning of automobile industry was cows. That how the automobile will scare cows and reduce the production of milks. It was also the amount of dust from unsealed road. At the beginning of industry, no one was thinking about the roll toll or air pollution. By 2000, 20 years ago, between 25 to 30 million people died in car accidents. This slide here shows some other positive and negative impacts of automobile industry. The same mentality can be applied to any other new technology or industry to see its impact. Please go through it and read. Taylor's scientific management with the goal of maximizing the management control and labor productivity was first developed by Frederick Taylor, and it was pursued by Henry Ford in his factory. It was based on mass production of many standard items. It took away the control from people who do the work, but successfully increased the production. Ford initially used OEM or original equipment manufacturer, but rapidly moved to complete vertical integration. Ford even had his own steel mill, which nearly bankrupted him. Division of labor to a level of minute detail, time and motion study to find the best and quickest way to doing work and to allocate time for doing it. Payments by piecework, later replaced by machine pacing. Making goods by manual labor or by machinery, especially on large scale, basically is called manufacturing. At the end of 19th century, manufacturing replaced agriculture as the leading source of economic growth in the US. China was involved in 20% of all manufacturing outputs in the world in 2010, and in that day, China became the largest manufacturer in the world, the title that US had for over a century. Sorry, it's like... In this short video, you can see the path the world took from first industrial revolution at the end of 18th century and the invention of steam power to fourth industrial revolution of embedded technology. I'm not to go to show it here, but it's very interesting video. I really recommend you to watch it, and shows how the industrial revolution started and went from the first generation to fourth industrial revolution. Infrastructure is a comparatively modern term for a very traditional focus of engineering activity. It covers all the fundamental facilities and systems that allow a modern society to function effectively. As the 20th century progressed, broad political issues began increasingly to affect decision-making on infrastructure. It is now recognized that choices about the location of a road, for example, or a bridge or a dam, are likely to advantage some members of the society and disadvantage some others. So the impact of a project on social and the environment depends greatly to its size. Larger project has wider consequences. Due to increased in large-scale projects, wider social impacts, secondary and unintended consequences should be expected. Everyone wants to hear about large projects. For example, larger refinery in Africa. You can hear from Sasol. Larger refinery in Africa. Largest power plant in Africa from Eskom. So all the things is about largest, biggest building in Santon or something like that. So it's like a psychological interest in having the biggest. So when you are dealing with the so big project, it means that the social impact and consequences of that big project will be much higher than a small project as well. Okay, so let's speak about a very simple question. It's about South Africa moving towards renewable energy. Looks very simple. So who doesn't like it? You spend a little bit at the beginning, but after that everything is free. It's very good for environment. But how about the social impact of it? Let's speak about the South African context. Do you know how many people are working directly in coal mining industry in South Africa? 93,000 people. If we add indirect employment and their families, okay, into this equation, something around 700 to 800,000 people will be affected by any decision regarding to eliminating of coal. Okay, so it's not just about environment, the social impact as well. Besides that, do you know what percentage of Eskom produce electricity coming from coal-fired power plants? 90%. So for example, you are using electricity in your house, you should think that 90% of it, of course if you don't have a solar panel and you are using Eskom, 90% of that electricity comes from coal-fired power plants. So when making decision to walk away from coal, you need to consider all those consequences and impacts. In the 19th century, the railroads were symbolically and physically important in uniting the US. In Britain and Europe, the impact of railroads were perhaps less dramatic than US. Their speed changed people's sense of place and opened up broader markets for goods and services. It also opened up colonial territories for exploitation. But what when we said that change of speed in railroad changed people's sense of place? For example, when I tell you like there is a place 5 kilometers away, you say okay, it's 5 kilometers, but previously when you wanted to walk 5 kilometers was so far in your mind. But now by having like an automobile industry or like let's say high speed, you say 5 kilometers is fine, I can go and live a little bit further or buy a house there. But previously it was not the case. Okay. With steel wheels on steel rails, the railroad still remains the most energy efficient way of transportation of large loads. Okay. A good road system also allowed the automobile to become the dominant mode of transport in the 20th century, often improving the quality of urban life and decreasing rural isolation. Building the interstate highway network in the US took 40 years to finish, and it was the largest engineering project ever. So you can just like imagine about the size of the project. In this slide you can see some of the engineering infrastructure for 2 important services of water and electricity: dams, desalination, or lots of other things related to water, sewage systems, water treatment plants, and electricity, different kind of power plants, coal, nuclear, and etc. Since the dawn of history, valleys have been associated with technological innovation. Natural resources have played an important part in this. In Egypt, the Nile provided easy bulk transport and reliable food supply for the workers. But you might ask, okay, it was long ago, why now we are talking about like valleys and we are just like comparing, I don't know, like 2 cases like a Coalbrookdale to Silicon Valley. They are not comparable, they are completely different things. But let's go through it and see if they are completely different, what is the characteristic of each of them. Let's talk about it. In late like let's say when the because we talked about Industrial Revolution at the beginning of 18th century in UK, and we all know about the Silicon Valley, so something that happened recently. Is not that long ago, but let's compare those two in the next 3-4 slides and see what we can get out of this information. So let's first start with Coalbrookdale. Coalbrookdale was a city in UK, and it was the birthplace of Industrial Revolution. In the coking process, sulfur was eliminated, or is eliminated because it still is using from coal, which increase its usefulness. In England, a coking process for smelting iron was patented in 1620, but it is widely acceptable that Chinese 2000 years ago were the first who used the same method, but there was no knowledge of that in Europe. As we mentioned, Abraham Darby, who was the son of a farmer and a blacksmith, patented a method to cast iron pots in sand in 1707, beginning of 18th century. In 1708, he moved to Coalbrookdale and took over a site with an existing furnace. Immediately, by using local coal, transferring technology from brewing industry, he built blast furnaces running on coal and produced very good quality iron. The iron Derby produced was ideal for casting the cooking pots. The plant at Coalbrookdale grew rapidly. He developed additional blast furnaces. He also added forges, rolling mills, and 32 kilometers of wagon track. The site location was also well chosen. It was close to England's busiest river system, and it was at the high ground sloping down to the river. So furnaces were water powered, so the amount of water in the river could limit the production. That was a downside of it. But how about the Silicon Valley? Formerly the Santa Clara Valley, now we call it Silicon Valley, is the industrial concentration consisting largely electronics and information corporation. It is located between Menlo Park and San Jose in San Francisco Bay Area. Since before Second World War, fundamental research on semiconductor technology has been conducted at Stanford University, which was keen both to spin off startup companies and to keep in close touch with them. So Stanford University played a huge role in shape of Silicon Valley. In 1937, with the encouragement of their electrical engineering professor at Stanford, Frederick Taylor, two Stanford graduates called William Hewlett and David Packard started a company that you all heard of it, HP, in 1939. And when Taylor became the dean of engineering at Stanford after World War II, he decided that there is a need for developing Stanford and the industry alongside each other. He did it as a community of technical scholars. In 1959, Stanford graduate William Shockley, who invented the transistor while at Bell Labs, returned to the Bay Area to found the company. 2 years later, 8 of his leading engineers broke away to found Fairchild Semiconductor Corporation, and by 1960 there were more than 30 semiconductor companies in Silicon Valley. In this slide you can see some of the common threads between Coalbrookdale and Silicon Valley. As you can see, even more than a century apart, they have some or more in common that we might thought before. Now the question is where the next one will be and what we can learn from these common threads. In the next two slides, I mentioned Coalbrookdale and Silicon Valley. In these two slides, I've uploaded two great videos on the history of Coalbrookdale and Silicon Valley. There is not enough time here to play them, but please watch it yourself. You won't be disappointed. They are very interesting. In the next two slides, by comparing Tesla and Edison, we would like to understand how different personalities and approaches to innovation can impact the development of a technology. By using the case study of Coalbrookdale and Silicon Valley, we just could find some kind of, like, of course, differences, because one, it's was the leading in the first industrial revolution, the second in the third industrial revolution. But even though between those completely two different concepts, we could see some common threads. But how about Tesla and Edison, two different people? Because we talked about two different countries, two different places, one based on industry, one started with the support from university. But how about these two people? How different personalities and approaches to innovation can impact the development of a technology? Edison was relying on try and error. So just like go to the lab and do whatever you want, you get the result or you don't. But Tesla was not like that. He hardly made any mistake. Tesla, unlike Edison, liked to work in a very small group. While Tesla was highly educated and was aware of the importance of scientific reasoning, Edison was mostly focused on craftsmanship. Tesla, from East Europe, today's Croatia, always was feeling that the media and society in the US were not supporting him, while Edison was receiving full positive coverage. Edison was not really into science or interested in science or mathematics or theory, just opposed of the Tesla, that he was very accomplished scientist and true believer in science. Tesla worked for Edison for a while, and after felt being ignored and financial robbed, left Edison. And as you can see here, there are like completely two different people, how they approach the process of innovation. And of course, both of them, they were successful people. That's the reason we are talking about those two. But it's another thing that shows that the personality and the approach to innovation can lead to different results as well. Okay, so basically that was the end of our second lecture. I also provided some extra bonus slides here, like if you can see, like bonus slide, if you want you can go through it and read, but those are for students that they are interested for more information, and the information presented in bonus slides will not be in class test, semester test, or final exam. Enjoy the rest of your day, and see you next week.